Gravitational waves are ripples in space-time created when massive bodies accelerate through space and time. They were hypothesized by Albert Einstein over 100 years ago, and they give us a completely new way of exploring the universe. Gravitational wave astronomy requires the most sensitive measuring devices ever made, what we call interferometers, and software and computers to extract the signals from detected noise. LIGO, the Laser Interferometer Gravitational Wave Observatory, first detected gravitational waves in 2015, 2 years after we began collaborating with XSEDE on high-performance computing. The waves LIGO detected came from the collision of two black holes over 1 billion light-years away. We've detected another black hole merger since then, and hope to detect many more sources of gravitational waves in the future with the help of our continually improving detectors and cyber infrastructure.
XSEDE is a network of the National Science Foundation cyberinfrastructure investments, which includes not only high-performance computing systems, but also experts who collaborate with researchers to move projects forward. LIGO first obtained access to XSEDE resources in 2013, and is now using the Open Science Grid as its standard interface to XSEDE and other shared computing systems. Since then, LIGO has been allocated millions of hours on XSEDE's high-performance computers, including Stampede from the Texas Advanced Computing Center and Comet from the San Diego Supercomputer Center. This collaboration also provided LIGO with access to XSEDE's extended collaborative support services. XSEDE staff had the expertise to help make the codes LIGO uses run more efficiently. Over the first year or so of the collaboration, they worked with LIGO to increase the speed of the applications, making them 8 to 10 times faster on average. The strategic collaboration between the two NSF-funded projects allows for accelerated scientific discovery, which also translates into cost savings for LIGO, on the order of tens of millions of dollars so far.
Syracuse University is home to one of the LIGO Scientific Collaboration's computing clusters, which carry out our astrophysical analyses. One machine manages the workflow, and another machine at UC San Diego then sends the jobs to compute resources, oftentimes XSEDE allocated supercomputers. We want to understand what a signal means and how likely it is to be noise or a real gravitational wave, and so we use XSEDE resources for the detection and validation process. This is where we bring all the data together for a high-fidelity analysis that tells us whether or not the signals we're seeing are real. Our analysis software wasn't always able to run on XSEDE systems, but staff from the Open Science Grid, XSEDE, HT Condor, and Pegasus, all NSF-funded projects working together, made that possible. XSEDE is helping astrophysicists add to their skill set by learning high-performance computing fundamentals through the transfer of knowledge. This is especially important for the graduate students in LIGO, as they often write most of the applications that we use.
The evolution of research and discovery requires us to be continually learning new skills. Researchers will always need to take their code and their hardware to the next level, and it's one of XSEDE's roles to enable that. This is why having a project like XSEDE is necessary to support these large-scale projects to meet their challenges.